Hello everyone, welcome to my channel. This channel is for ICSE Physics class 8, 9 and 10. To know more about the curriculum, to get more videos of physics, what you have to do? You have to like my channel, you have to subscribe my channel and click on the bell icon to get the further notification. Today, in this video, I am here to discuss about a topic of graphical representation of linear motion. The title only, it is graphical representation of linear motion. Graphical representation means when we represent the data, when we represent the motion of a body in graph. Linear motion means when a body move in a straight path, which is called translatory motion, rectilinear motion or linear motion. So let to come what is a graph mean first. First thing to know about the graph. What is a graph? Graph, whenever we will get a data, that is raw data, we can express or we can show them in the form of tabular form, in the form of table, or tabular form, or graphical form of graph. Graph is a pictorial representation of the given data. Graph which shows the variation between any two or three quantity. Graph is a pictorial representation or diagram that represent the data values in organized manner. Here we will able to know about the variation of two different quantities with respect to one another. This graph, when you are taking two-dimensional graph with x and y two axes, in this where both are mutually perpendicular to each other, which will form four quadrant. In that, in x-axis, right side taken as positive, left side is negative. Y-axis, upward direction is taken as positive and downward direction is taken as negative. X-axis with independent variable or fundamental quantities, whereas y-axis with a dependent variable or derived quantities. In this graph, when we will get a straight line which signifies the uniform variation between any two given quantity, because y-axis value is dependent on x-axis, so uniform variation means there is a uniform change of y-axis value with the value of x-axis. In the graph, we will get one more term which is called slope. To find the slope is the ratio of y-intercept to the x-intercept, which means the change in y-axis to the change in x-axis. What you can say in the mathematical expression as y2 minus y1 by x2 minus x1, where y2 is the final value of y, y1 is the initial value of y, x2 final value of x, and x1 initial value of x. Means how much change in the x-axis and with due to which how much we got the change in the y-axis, the ratio is the slope. Slope, to find the slope of uniform variation, any point we can take to get the correct slope, but in case of a non-uniform variation, we have to take the value which cover more than half part of the graph. So this is all about a graph. This is a fundamental concept of a graph. Now we'll come to our topic where we'll get graph for motion. A linear motion of a body can be studied with three types of graph. One, but displacement will change with the time. It is called displacement time graph. Second, how much the change in velocity with respect to time, which is velocity time graph. And third one, change of acceleration with the time, which is called acceleration time graph. So in this video, we'll read in detail about different cases by taking displacement time graph, velocity time graph and acceleration time graph. Let to come first displacement time graph. In case of displacement time graph, displacement as a dependent quantity, derived quantity, so it is always taken the y-axis, but time which is independent, time which is fundamental, always taken this one the x-axis. So to find the slope, change in displacement axis or y-axis to the change in time axis or x-axis, you will get the slope. The slope of displacement time graph gives velocity, because velocity is the displacement by time and velocity having the SI unit meter per second. Case 1. Case 1, when body is not moving, body at the rest position or body is stationary, body is not changing its position. At that point of time, you will get a graph which is parallel to the x-axis. Here you can see a red color graph, the line, red color line which shows the graph which is parallel to x-axis. There is no graph where a graph is parallel to y-axis, because x value or the quantity which is taken in the x-axis is always independent. It's not depending upon y, as there is no change in the displacement. Change in displacement by time is the velocity. As there is no change in the displacement, we will get velocity here 0. Second case, in case of uniform change in the displacement, case 2. In case 2, a body is moving in the straight path with uniform velocity. Uniform velocity means with equal change in the displacement, equal change in the time. Means when we will take slope of displacement time graph, we will get velocity. So here let us take one data. At 0 second, displacement of the body is 0. At 1 second 10, at 2 second 20, 3 second 30, 4 second 40 and 5 second 50. So that's what we have represent that in a graph. Time in the x-axis and displacement in the y-axis. To find the slope of this graph, we have taken two parts. One is BC, the change in y-axis, AC or CA as a change in x-axis. BC starting from 40 to 20 means here 40 is the final value of y and 20 is the initial value of y. So 40 minus 20, y2 minus y1. At the same time, for x value is 4 minus y value is 2, 4 minus 2. So 40 minus 20 equal to 20, 4 minus 2 equal to 2. So 20 by 2 or 10 meter per second is the slope of this graph, or it is the velocity of this given data. Next one, when we will come to the next part, case 3. In case 3, we will get a graph when a body is moved with a variable velocity, means equal change of displacement or unequal change of time, or unequal change of displacement in equal interval of time. So here it is given to us a data where displacement time both are changing but both are not in equal. So in this type of graph, to find the slope, we have to take a tangent. Tangent means a straight line which touches the graph in one single point. And here we have taken 2 points. One is the top part, and down we have taken another point, because here BD is the line. What you can say is a tangent which touches this graph in one point A. Here you can see one point A. So here to find the slope of tangent BD is equal to BC. BC, the change in y-axis, this part, BC, change in y-axis, this one, to the DC or CD, this part, change in x-axis. Change in y-axis we got at B point 50 and in C point 10, and for x-axis change at C point 7 at D point 3. So 50 minus 10 by 7 minus 3, which is 40 by 4 or 10 meter per second as the slope of this tangent. Means for variable data or variable velocity, we have to take the help of tangent. Next one, in case when we are taking a velocity time graph. Velocity time graph is important graph, because in velocity time graph we will get two quantity. First thing we have to know, velocity time graph time, we have to keep velocity as a dependent variable. So a derived quantity, velocity always in y-axis, but time which is independent, which is fundamental quantity, always taken in the x-axis. Next one, we can determine from here two quantity. First quantity is the displacement of the body, means how much the body will move. Second thing, the acceleration. Rate of change of velocity is called acceleration. So acceleration we will be able to know from velocity time graph. Here, how to find the displacement? Whenever we will take a graph, the area, the surface inside the graph and x-axis, or the surface enclosed inside the graph and the x-axis, will get the displacement. That can be a shape of triangle, that can be a shape of rectangle, square, or any other closed figure. You have to take the formula to find the area. And second, to find the acceleration, we have to take the slope of that graph. Slope, which is the change in y-axis to the change in x-axis, or y2 minus y1 by x2 minus x1. So in case of to find the acceleration, we have to take the help of slope of this graph. Next is the velocity time graph. Here you can see a velocity time graph where first you will look, if you will observe closely to this graph, first this graph is just uniformly increasing. Then at a particular point is constant, then it is going down. Means first uniform acceleration, then constant acceleration or constant velocity, or zero acceleration. When it is going down means uniform retardation. Or area inside this particular figure, which is in the form of a trapezium, that will give us the distance traveled by a body or displacement of the body. So by using this velocity time graph, we will find acceleration, we will find the displacement of the body. So next, this is the case 1. Here in case 1, we'll get when the velocity of a body remain constant. Means a body is moving from one place to another without changing its velocity. Velocity remain constant means at every instant of time you will get the same velocity. When you will take the graph, in this graph you will get a graph which is parallel to x-axis. So in this graph, if we look at A point, also velocity is 40. At B point also velocity is 40. That means there is no change in the velocity. No change in the velocity means there is no acceleration, because acceleration is the rate of change of velocity. If we will find the acceleration here, B point 40 minus A point 40, because change in y-axis, because if we look here, there is no change, that means acceleration is 0. To find a displacement, displacement is the area enclosed or surface enclosed between the graph and x-axis. Here if we look A, B, D, C or A, C, D, B, this is a shape of rectangle. To find the area of a rectangle, we are using the formula L into B. Here L or AB distance, if we look, 12 at the B point or D point and 6 at the A point or C point, which is the change in x-axis. So 12 minus 6 into AC or BD part, if we look, it is 40 minus 0. That means 40 minus 0 into 12 minus 6. What we will get the displacement as 40 into 6 or 240 meter. Whereas acceleration for this type of graph, it is 0. Next case, when a body is moving with uniform velocity. Uniform velocity, a straight line graph always signifies a uniform change between two quantities. So when you will get a straight line graph, here if you look 0, 0, at 1 second 4, at 2 second 8, at 3 second 12, 4 second 16, 5 second 20. To get the slope of this graph, to get the acceleration in this graph, we have to take y2 minus y1 by x2 minus x1. If we take any 2 points, we can find the slope. Slope of this line will give the acceleration. To find this acceleration, and we have to take y2 minus y1 and x2 minus x1, and area enclosed give the displacement. So we can find here the slope as 20 minus 0, which is the y2 minus y1, the extreme limit in y by the minimum limit in the y, and extreme limit in x minus minimum level of x or starting point of x. So 20 minus 0 by 5 minus 0, 20 by 5, which is giving 4 meter per second square. So 20 by 5 will give 4 meter per second square, which is acceleration. And if to find the displacement, we will take the help of formula, because it is forming a triangular shape between slope, between the graph and x-axis. So to take the help of formula half into b into h. So half into 5 minus 0 into 20 minus 0. So half into 5 into 20, 10 into 5, which is 50 meter. So next case, if we will come to the next case, in case number 3, when the body is traveling with a uniform velocity for a certain period of time, then the velocity change. In this case, if we look this type of a graph, to find the displacement, we have to take the help of all these three shape, where A, B, C all are the shape of a rectangle. To find the shape of any rectangle, we have to take the help, first thing, we have to take the help of formula L into B. For A, 2 into 2, which is a square. For B, the 4 minus 2 into 3. And for C, it is 10 minus 4 into minus 3. That means you got total displacement 4 plus 6 minus 18, which is minus 8 meter. But total distance, if we look, because distance never become negative. So distance case 4 plus 6 plus 18, which is 4 plus 6, 10, 10 plus 18, 28 meter. So distance and displacement here change. Next one. When we'll come to the next part of case number 4. In case number 4, when the body is in motion with variable acceleration, in this type of figure, when we'll get a variable acceleration, we'll get a curved line. In this case, we have to take two tangents. Here if we look for one surface, we have taken one tangent CD, which touches the graph in Q point, and AB, which touches the graph at the P point, the top. So we have to take the slope from both sides to calculate the acceleration. Next one, when we take on numerical problem here, it is given to us one data. In this data, if we look, this graph is touching to the point 15 in the y-axis, and last it is touching here 6 in the x-axis. So to find first on the acceleration between A to B part with the uniform increase in the acceleration or 0 to 2 seconds. So in 0 to 2 seconds, to find the acceleration, you have to take the help of slope, which is y2 minus y1 by x2 minus x1. y2 15, y1 0. 15 because origin at the A point is 0, 0, 0 point, that is origin. So 15 minus 0 by 2 minus 0, 15 by 2 or 7.5 meter per second square. But when it will come to B to C, 2 to 5 seconds, as there is no change in the velocity, we will get the acceleration 0. But when we come to C to the last point, or 5 to the 6 second, you will get here at last y-axis value is 0, at top at C point y value is 15. So 0 minus 15 by 6, so final time 5 is the initial time, 6 minus 5. So you will get minus 15 meter per second square as the acceleration. But when you come to displacement, in case of displacement of the first part A to B, as it is forming a triangle ABE. To find the area of a triangle, formula is half into base into height. Here base is 2 minus 0 and height is 15 minus 0. So half into 2 into 15, which is 15 meter as the area between AB. Then when we'll come to BC part, it is forming a rectangle BEFC, or you can say BCFE. To find the rectangle area, we are using a formula L into B. So L, which is 5 minus 2, and 5 minus 2 is the length, and breadth part if we look 15 minus 0. 5 minus 2 is 3 and 15 minus 0 is 15. So 15 into 3 will get 45. Next one, if we look CD part or 5 to 6 second part, again it is forming one triangle. To find the area of a triangle, half into base into height. Here base is 6 minus 5, so half into 1 into 15, so you got 15 meter. So this way we can find the acceleration and displacement for a given velocity time graph. Next, we are having another type of graph which is called acceleration time graph. In this acceleration time graph, acceleration is always taken the y-axis and time in the x-axis. For first case, when a body is stationary or rest, or we can say body is moving in a uniform velocity where acceleration is 0. That case, we will get a graph where the graph will coincide with the x-axis with every point of time, every instant of time acceleration value is 0. Second case, we will come to case 2. In case 2, you will get here, if the body is increasing uniformly with time, acceleration remain constant. So that case, we will get a graph where graph is parallel to x-axis, because for every change, every uniform change between the velocity and time, we will get the same acceleration, or acceleration remain constant. But when we will come to retardation, that case 3, that case we will get another one graph by retardation constant. Retardation means negative acceleration, so we have to take down of side of the y-axis. So we'll get a graph which is again parallel to x-axis, but the position of the graph is down. Means this is about displacement time graph, velocity time graph, and acceleration time graph. So to get some more videos of motion and physics, mainly this channel is for physics, so to know get some more videos, you have to subscribe my channel, like my video if you feel it is helpful for you. Thank you.